Hello students, this is lesson U6A07a. By the end of the lesson, you should be able to say, I can write equations, graph, and solve problems involving circles on a coordinate grid. So what we're going to try to do in this lesson, okay, for the past couple lessons, we've been studying and analyzing all the different properties associated with chords and secants and tangents, okay, and the various angles that can form and then the lengths that it can form. What we're going to do now is we're going to transfer the circle from just a regular old plane onto a coordinate grid, and we're going to try to analyze a circle that way. In order for us to do that, though, we first need to be able to describe said circle on the coordinate grid, which then calls for the equation of a circle. Now, what is the equation of a circle? The best way to think about this, okay, is to think about it logically. When we have a circle on a grid, in order to describe this circle, okay, we need to locate where that center is. So first we need to know what is the center. Because if we can pinpoint where the center is, that will give us a general idea of where that circle is going to be located. Second is we need to know what is the radius of the circle, because if we know the center and we know the radius, then we can draw that circle, right? So the equation must involve these two facts. So in order for us to accomplish this, okay, and the equation of the circle is supposed to describe all the various points that are on this circle. Well, how do we describe that? How do we describe all the points that are on the circle? I have no idea what that is, right? But what I can say is, okay, let's say if I call the point over here x comma y, which is some point on the circle, and then the center I call h comma k, which is the center, what I do know is that the distance between them has to be r. Well, in order for us to fulfill this requirement, okay, well, what has to be true? Well, I know that x minus h, quantity squared, plus y minus k, quantity squared, has to equal to r squared. This is just a Pythagorean theorem. And as a matter of fact, this is the equation for the circle. You may be wondering, what, why, how? Well, that's because this equation describes every point on the circle, if you know the center of the circle and if you know the radius of the circle. So here's the equation again, drawn a little more neatly. So again, this circle equation is simply the Pythagorean theorem that describes the length of r from any point on the circle to the center. That's all it is. Let's see what we can do with this. So the center and diameter of a circle is given. We need to find the equation of the circle. Pause the video to see if you can try to do this on your own. So again, according to the circle equation that was given to you in the previous slide, right? The circle equation involves not the diameter, but instead it involves the radius. We understand that the radius is equal to half of the diameter, so therefore the radius in this case must be 4. Well, looking at this, okay, I understand that this is the general format for the equation of a circle. So therefore, in this equation here, all I got to do is just make the appropriate substitution. I know that h and k are these values. I know r is this value, so I just make the appropriate substitution. And what I will end up with is x minus negative 3 quantity squared plus y minus negative 4 quantity squared will equal to 4 squared. And actually, you can leave your answer like this, but I decided to clean it up a little bit to make it a little nicer. So again, the coordinate is negative 3, negative 4. Notice what happens inside of the parentheses here. It becomes plus, right? Okay. So the next problem here, the equation of a circle is given. Graph the circle on a coordinate grid. So this is what I'm asking you to do. I'm asking you to graph the circle on a coordinate grid. So hopefully if you guys have graph paper and handy, this is the time to use it because it would help immensely if you did. So pause the video to see if you can figure this out on your own. What I would do if I were you guys, first identify where's the center. And the second thing I would ask you to identify is what is the radius before you try and graph this. And if you are able to identify these two things, then graphing this wouldn't be too big of a deal. So go ahead. Hopefully you guys had some time to think about this. So the center and radius, the center, as it turns out, is -2, 3. And the radius, well, it's the square root of 9, which is 3. So if we were asked to find to graph the circle that's being described by this equation, first we would have to pinpoint where the center is, and that's -2, 3. And it is rather challenging to draw a circle without the aid of a compass. However, knowing that the radius is 3, what I can do is, and artists do this all the time, if they're asked to draw a circle, we draw parts, bits and pieces of the circle at a time. So what I know is from -2, 3, I'm going to go up, down, left, right, okay? 3 units. So I have 3 units there, 3 units there, 3 units there, and 3 units there. And what I want to do is from there, okay, I can then just make a decent sketch of what it is. Again, if you don't have a compass handy. That's not bad, right? Of course, I have a computer software so I can draw a perfect square circle. But if you don't have that, okay, if you're, let's say, taking a test, okay, you're doing something, you know, for the Regents, okay, then this would be the, then making a sketch would be the way to go. Next, the equation of a circle is given. A point on the circle has an x-coordinate of -2. What are the possible y-coordinates? So pause the video to see if you can figure this out. Hopefully you guys had some time to think about this. So imagine this with me, right? You have a circle, and you're told the x-coordinate. If you recall a thing or two about Algebra 1, a circle is not a function. So for every x-coordinate on a circle, there is a potential for there to be 2 y-coordinates, right? This would fail the vertical line test. So by the end of this problem, you should expect there to be a possibility of having 2 answers. So let's take a look at this. So I know that the x-coordinate is -2, and we're looking for the other possible y-coordinate. And this point that we're looking for is supposed to be on the circle. That is the emphasis. So what are the possible y-coordinates that are on the circle, a point on the circle? So what I'm going to do is, if I know the x-coordinate, I'm going to substitute -2 into the x-coordinate of the circle. And I'm going to solve for the y-coordinate with that potential x-coordinate. So I'm just going to go through the orders of operation and solve for b. Subtract 1, b minus 1 is equal to 15, or b minus 1 taking the square root of both sides is equal to square root of 15 plus or minus square root of 15, because when you're taking the square root of both sides, you end up with plus or minus. Remember that. And then we add 1 to both sides. So b will end up being 1 plus or minus square root of 15. And this makes sense, because if I draw out the circle, which you are not asked to do, however, for visual reference and for better understanding, I'm going to draw it out. We have a circle. We have an x-coordinate of -2, which is going to be right here and right there. It makes sense that the y-coordinate would be close to 5 or close to -3, which is exactly what we have. We have two coordinates. Okay, last problem. What is the equation of a circle with center 1, 2 and a point on the circle being 2, 4? pause the video to see if you can give this a shot. So hopefully you guys had some time to think about this. I know that the center is supposed to be 1, 2, and then there's another point on the circle, which is 2, 4. So therefore, the distance between them has to be something, right? So what we are going to do, we're going to quickly solve for what the radius is. So I know that the change in x is 1, and the change in y is 2. So therefore, the hypotenuse here must be square root of 5. And being that 1, 2 is the center, and I know the equation, the format for writing the equation of a circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. All I got to do is just make the appropriate substitution. So this is simply x minus 1 quantity squared plus y minus 2 quantity squared, and that will equal to r squared, which is square root of 5 quantity squared, or x minus 1 quantity squared plus y minus 2 quantity squared equal to 5.